Okay, so in question 13, it says, take measurements from the photographs, show that the horizontal speed of the pellet is about 300 meters per second. Assume that the photograph is shown actual size. So we've got two successive frames. That means one frame after another. And we're told that there are 9,600 frames per second. So we know from this and the fact that it is successive frames, we can find the time between the frames is going to be 1 over 9,600. So the time between the frames, 1 divided by 9,600, is in standard form 0.104 times 10 to the minus 3 seconds is the time between the frames. Now, to measure the distance, I've made this is the same size. This is a bigger one, so I need to measure the distance that the pellet that the pellet moves. So you can see the front of the pellet starts here, and in the second picture, the end of the pellet is here. So we need to measure that distance. So I measure that distance there, and I get 2.8 centimeters. The distance that the pellet moves is 2.8 centimeters. Distance moved is 2.8 centimeters. That is 2.8 times 10 to the minus 2 meters. So now we can find the speed is the distance over the time. So 2.8 times 10 to the minus 2 over 0.104 times 10 to the minus 3 to give me a speed 2.8 10 to the minus 2 divided by 0.104 times 10 to the minus 3 is 269 meters per second. So it is about 300 meters per second. Okay, so it then says the droplet fell 33 centimeters from rest before colliding with the pellet. Calculate the time for the droplet to fall this distance. So the droplet is starting from rest and it falls a distance of 33 centimeters. So we've got U, we've got S, we've got the acceleration is 9.81. So we need to just use one equation to find the time, which is S is equal to UT plus a half a t squared. So we've got 0.33 is equal to 0t plus a half of 9.81 t squared. So t is equal to the square root of 2 times 0.33 over 9.81. Square root of 2 times 0.33 divided by 9.81 to give me a time of 0.259 seconds. Notice I'm giving my answer to 3 significant figures. It's as we should be in all of these. Okay, so before the photographs were taken, the release of the droplet started a timer. After a short delay, the pellet was automatically fired and took 1.43 times 10 to the minus 3 to reach the droplet. If the pellet is to hit the droplet, the resolution of the timer must be sufficiently small. Explain one factor that affects the size of the resolution required. So we're seeing here that this time is much smaller than that time. So the pellet is released and that timer starts, and then the pellet falls for this amount of time, and then the pellet is fired and it takes this amount of time to reach the droplet. So this here is the limit of the resolution. That time is quite big, that time is really small. So the time taken for that to happen is really small. So we need a resolution of at least this. Okay. The other factor is the distance, we want the droplet of water to hit the pellet. So as it's falling, there is we want them to hit. So this size here and this size here are really important, because if we want them to hit, then these are really two very small sizes. So we've got two factors really. We've got the time that it took to reach the droplet. It's got to be at least that precise. It's also got to be precise enough for the pellet to hit the droplet. The timer must have a resolution of at least plus or minus 10 to the minus 3 seconds. Okay, because so that the pellet is fired at precisely the correct time. Okay, another factor is the size of the pellet itself. If the pellet was much smaller, then you'd have more difficulty trying to hit the water droplet. The size of the pellet is really small, is also an important factor. If the pellet was smaller, then there is less chance that the pellet will hit the water droplet. Okay, so that's question 13.